Okay, so in this final video for today, I want to talk about identities and their connection with universal cells. And I've been using universal and maybe the word thin and isomorphism sort of all interchangeably to mean these sort of blue cells that we keep getting as witnesses for universal properties. So these things are sort of all interchanging, and I apologize if my terminology is slightly inconsistent. But in any case, let's start out by thinking about how to get identities here. I mean, another feature we should have of any good theory of categories is objects should have identities. So let's give ourselves an object called X. How should we define the identity on X? Well, first of all, it should be defined, it shouldn't be unique in any sense, for the same reason that composite shouldn't be unique. We're hoping to define it by universal property. And the trick to getting identities into the mix is to use this other form of extrusion where we extrude a drop. So if I extrude a drop on X right here, Orchard is telling me that this is a fillable condition. So what I'm going to do is I'm going to fill it, and I'm going to name it IDX and def IDX, and then we'll talk about why this is a good idea. Well, first of all, what is IDX? It's a one cell from X to X, and by the way, if you click on it over here in the environment, it really, when I pull it out of this picture, it really does have that shape. It is a one cell from X to X. It's only when it's included in this picture together with its universal cell that it needs to be wound up in this particular way. And remember, all these blue cells, all universal cells, are in a sense witnessing that their target, which here is IDX, you can see because it highlights that line in red, is a composite of the pasting diagram in front of them. Well, here the pasting diagram lying on top of IDX has no cells in it. So one way to read what the identity is it's the composite of the empty pasting diagram. And another way that you might read that is here X is a loop from X to X. So if you like homotopy theory, it's a loop from X to X, but it's also a loop with a filler. So you can also think of this definition universal cell here as a null homotopy of that loop. That's maybe another way to think of how the identity is acting in this situation. So there we go. So that's how we get identities into the mix. And if you make another instance of the identity by filling a drop on X again, Orchard will force you to name it differently, because every time you go back and ask for a filler, Orchard is telling you it's going to give you a different one. You can't guarantee to get the same one. But you'll be able to prove different identity cells to be universally connected to each other one dimension higher. So you'll be able to derive more coherence laws. For now, let's see what we can do with the identity cell. And to do that, let's get a new window here. So I have my f, and this time I'm going to add another variable y. And this time I'm going to add an arrow from x to y. But I'm going to do something special this time. I'm going to click this little thin button. So what this is going to do is it's going to give me an arrow which I'm assuming to be thin. So you'll notice the difference is now it's not this nice blue color that we were getting for arrows, which Orchard knew to be thin by consequence of its rules. This one is purple because it's assumed to be thin. I'm not deriving that information from Orchard. I'm telling Orchard to assume that this is a thin cell, or a universal cell, or an isomorphism from X to Y. All those things I'm going to sort of use interchangeably. Okay, so what would we expect to be able to prove about this universal cell connecting X and Y? Well, if it's acting like an isomorphism, we should expect to be able to find an inverse. So let's try and do that. Let me extrude around Y. And now let me stick X in that box right there. And now let me extrude around here, around these two cells, and I'll notice that the back cell here that I'm trying to fill now is exactly a morphism from X to X. Well, I know one of those. I created one earlier called the identity. So I can stick that in there. And sure enough, Orchard has told me this is a fillable condition. So when I fill it, I'm going to call the filling cells F inverse and def F inverse. Okay. Great. And so I named it F inverse because I claim that X for all intensive purposes like an inverse to F. Notice it goes back from Y to X, and it is universal. Orchard was able to deduce that from the positions of the cells we filled. So let's try to prove one more thing about it. What else would we expect about F inverse? Well, if I open myself a new tab and then stick this in here, excuse me, I guess it goes here. Well, I have F and F inverse, and I could compose the two by hitting Control C, and I'll call that F inverse. I'll put a little circle for composition. Def F inverse F. So now I compose these two things, and what would I expect? Well, if I compose these two, I have an arrow from X to X. I would expect that should be the identity. And again, there's no other way to say should be the identity other than to say it's connected to the identity on X by a universal cell. Let's see if we can prove that. It shouldn't be too hard. Let's extrude around that. Let's notice that the identity on X fits there just as well. So I'll stick the identity X on there. Now I'll extrude around these cells up here. And it turns out if I look at this cell, I'm looking for a cell F and F inverse mapping to the identity. But if I go back here and look at the definition of F inverse, it's exactly a cell of that shape. So I can use that. And sure enough, I get, again, a fillable condition. So I fill it in. And I will call this inverse. I'm not sure if it's left or right. I'll just choose left for now. And you can correct me if I'm wrong. Sure enough, if we look down here, what we've produced is a universal cell, meaning an equality or an isomorphism or whatever you'd like to call it, between F composed with F inverse and the identity. Right, so this is the connection that these universal cells have to isomorphisms. When I have universal cells that are sort of globular shape, I can create inverses and I can connect them with the definition of identity cells as compositions of empty things. Okay, so I guess we'll leave it there for now.